This is part 2 of section 3.4 in notes for PreAP PreCalculus, looking at multiplicities and end behavior of graphs. Now let's consider how we might be able to locate the zeros of a polynomial function numerically. Consider this function right here that we investigated earlier, and the graph is shown. Let's find each pair of function values in the table on your calculator and answer the questions that follows. So we're supposed to find h of -2 and h of -1. So what we're going to do is we are going to turn your calculator on, hit the y equals button, and we're going to type this function into it. Now to use the table feature, I don't know how proficient you are with using the table feature, so I'm going to walk you through that. Anytime you want to use the table, you have to first set the table. So I'm going to hit second table set. Let me explain what each of these options are, and then we will discuss what we want ours to be. The first one, table start. If this is going to generate x values, where do you want it to start? Right now it's starting at 0. The next one says triangle table, that's delta table, change in the table, it's 1. So right now if we left it as it is, it would start at x equals 0 and then add 1 and then add 1. So it'd be x equals 0, 1, 2, 3, 4, 5. For us, none of that matters because we're going to go down here to the independent variable and we're going to change it to ask instead of auto. So I highlight ask, I hit enter. Now I'm going to hit second table. I have x and y columns here. We were supposed to figure out what h of -2 is. I already got h into y1. So I type in a -2 and I hit enter and it gives me the y value of -9. I'm supposed to also figure out the y value at -1. Then the next question asks for the y value at 0 and at 2. So I just wanted to show you how to use the calculator on that. And I'm going to go back to the notes and transfer these numbers over. All right. Now, what is the point of this? Let's try to get to this right here. From the graph, clearly h of x has a 0 between -2 and -1. So here's -2, here's -1. It's got to be a 0 between. We can see it's crossing there. Explain how you're finding from the values of h of -2 and h of -1 above shows there is a 0 between -2 and -1. So here's the point, and then we'll write this down formally. This y value is negative. This y value is positive. If this graph is continuous, and it is because it's a cubic function, every number between -9 and 4 has to be accounted for between these. There's no way to get from -9 to 4 without crossing through -8, -7, -6, -5, all the decimals between those, zeros between these. So it has to cross, the graph has to cross someplace between -2 and -1 because the y value of -2 is negative and the y value of -1 is positive. So let's write that down formally. Since h of -2 is -9, which is less than 0, the graph of h of x is below the x-axis at x equals -2. So we have established from that sentence that at -2, the graph is below the x-axis. Since h of -1 is equal to 4, which is greater than 0, the graph of h of x is above the x-axis at x equals -1. So we just established that at -1, the graph is above the x-axis. H of x is continuous from -2 to -1. There's no breaks in the graph. And goes from below the x-axis to above the x-axis. What conclusion can we draw from that? So since the graph is continuous from -2 to -1, and it goes from below the x-axis to above it, the conclusion that we can draw is that a 0 is guaranteed to exist between x equals -2 and -1. Guaranteed. Does the same reasoning that you described concerning the 0 between -2 and -1, that's from over here, Does that same reasoning hold true for the existence of a 0 between 0 and 2? Explain your reasoning. Well, if we just look at this without looking at the graph, at 0, the graph is above the y-axis because 3 is bigger than 0. At 2, the graph is also above the x-axis. So that means we are not guaranteed that this crosses the x-axis. Now, it clearly touches the x-axis here, but since these are both positive, we are not guaranteed there's 0 to be there. Formally, since h of 0 equals 3, which is bigger than 0, and h of 2 equals 7 is bigger than 0, the graph of h of x is above the x-axis at both x equals 0 and x equals 2. This does not guarantee a 0 exists between 0 and 2. Now, all that being said, it is possible for 0 to exist. We're just saying that it doesn't guarantee it. All right, based on what you've just seen, what inferences can you make about the existence of a 0 of a polynomial function if you know the value of a function at two different x values? If f of a and f of b are opposite signs, so that means one's above the x-axis and one's below it, a 0 of odd multiplicity is guaranteed to exist between x equals a and x equals b. Now, that doesn't mean only one 0 could exist. There could also be, it's possible, there could be odd multiplicities that exist as well. There could be a dozen x-intercepts. This is simply saying that if f of a and f of b are opposite signs, there must be minimally at least one 0 with odd multiplicity. 2, if f of a and f of b are the same sign, a 0 of odd or even multiplicity might exist, and it might not, between x equals a and x equals b. Let's see if we can use a table to determine if we understand what those two inferences are. A table of values below represents values of a quartic function. That means the biggest degree of the polynomial is 4. Or the actual, not the biggest degree, the degree is 4. The term with the biggest degree is a 4. The function has a negative root. Oh, that's important. Whoops, pardon me. And 2 distinct positive roots. Distinct means 2 different positive roots. So we got this table. Let's see if we can pick out anything here. Now, I got some things already marked on here. 1 is a root. It's a 0 because we know that the y value is 0. So here is a root, x equals 1 for sure. That's one of 2 distinct positive roots. Now I have this marked here from 40 to -8, the y values. The reason I have this marked, this is positive and this is negative. Someplace between these, it has to cross the x-axis. There has to be an odd multiplicity for that 0 because it crosses from being above to below. Over here, same thing. We're going from a negative y value to a positive y value. So the graph has to cross the x-axis someplace between them. So that's just big picture. Let's read the questions. Are there any roots of f of x specifically identified in the table? There sure is. It's right here. What is the multiplicity of this 0? Explain your reasoning to both questions. Well, f of x has a 0 at x equals 1. It appears that the graph of f of x is tangent to the x-axis at x equals 1 because the graph of f of x is below the x-axis at x equals 0 and x equals 2. Now, here's how we know for certain. No, I shouldn't say that. I shouldn't say for certain. It's possible there's another root between 0 and 1, decimals. It's possible that there's one between 1 and 2, decimals. Possible. So that's why I use the word appears. The root of x equals 1 likely has a multiplicity of 2 because f of x is quartic and the other 2 sign change, and there are 2 other sign changes in the table. So we know that it's quartic, we're told that. So the degree of this is 4. So the multiplicities have to add up to 4, assuming there's no imaginary roots. So if this one's 2, because it appears to be even, because it looks like it's tangent, and each of these are 1, 2 plus 1 plus 1 is 4. That's why we're saying that it's likely to be 2. Now, this multiplicity couldn't be a bigger even number. It couldn't be 4, because then we would have 5, 6. It's too many. So its multiplicity is going to be 2, or it's, yeah, let's just leave it at that. Based between which two x values in the table is there a negative root located? Explain your reasoning. Definitely between x equals -4 and -1, because the y value signs are changing. F of x has a negative root between x equals -4 and x equals -1, because f of -4 is bigger than 0 and f of -1 is less than 0, which means the graph crosses the x-axis between x equals -4 and x equals -1. Between what two values in the table is the second distinct positive root located? Explain your reasoning. So we're saying it's between 3 and 5 because these y values are changing signs. F of x has a positive root between x equals 3 and x equals 5 because f of 3 is bigger than 0. That's wrong. I got that written wrong. F of 3 is less than 0. Whoops. Excuse me. F of 3 is less than 0 and f of 5 is bigger than 0. My apologies for that. Which means that the graph crosses the x-axis between x equals 3 and x equals 5. All right, that concludes the notes for section 3.4. Please spend some time looking at the rules for multiplicity. Just to sum up, if it's an odd multiplicity of the root, then the graph crosses the x-axis. If it's an even multiplicity for the root, then the graph is tangent to the x-axis. If it's an odd multiplicity of 3 or more, then the graph changes concavity at the x-intercept. And if it's a multiplicity of 1, then it crosses it without changing concavity. Please do the assignment as noted on the website.